This is the solution video for the Chapter 1 practice test that is in the workbooks. And this is not mandatory that you watch the whole thing. What I suggest is that you maybe speed ahead and check solutions. And then if there's an issue with a problem that you have, maybe you go and you watch that one solution. Okay, you do not have to watch the whole thing. This is something that's not graded. So use it to your advantage however you like. So problem 1 says to find the distance between these 2 points. And remember, we have the distance formula. And when doing that, I'm going to find the difference between the x coordinates and the y coordinates. So inside the square root, I have 6 minus negative 4. 6 minus negative 4 squared plus 4 minus negative 3, and that's squared. So this becomes 10, and 10 squared is 100. And this becomes 7, and 7 squared is 49. And if I add these up, I have 149, and that is in simplest form. So I'm not able to find any perfect square factors that go into 149, so that is the solution. Number 2, we're finding the midpoint, and I included the formula here. We're going to add up the x coordinates and divide by 2. That'll tell us halfway between each of the x coordinates, and then the same thing for the y's. So for the x's, I have 2 plus 12 divided by 2. And for the y's, I have 5 plus 3 divided by 2. 2 plus 12 is 14 divided by 2, and 8 divided by 2, and this gives us 7 and 4. So the point 7,4 is halfway between the two given points. Number 3 asks us to graph this equation by plotting points, and it says to show work for at least 3 points. So I'm going to make a table, and looking at this, when I cube something, my numbers will increase very quickly. So if I put in just a small number like 0, I have 0 plus 4 is 4. I cube that and I get 64 minus 5 is 59. So this is my y-intercept actually, and that would be very high up on the y-axis. So what would make this be 0? Because if I can get a 0 here, I would have a y-coordinate of -5, and that's a little bit more manageable. And if I look here, I have, if x were -4, and I add this together, I get 0. And 0 cubed is 0, minus 5 is -5. So when I find something that gives me some pretty manageable numbers, how about if now we look for some numbers that are close to -4, like -3. -3 plus 4 is 1. 1 to the 3rd power is 1. And 1 minus 5 is -4. How about -2? -2 plus 4 is 2. And 2 to the 3rd is 8. 8 minus 5 is 3. How about -1? I know it says at least 3 points, but let's do a few more just to get a better idea of what this looks like. -1 plus 4 is 3. 3 to the 3rd power is 27. and 27 minus 5 is 22. So here we're getting very large numbers, and if I keep going up to, if I went to 1, 5 cubed is 125, so this would be 120. All right, so let's plot what we have here, maybe not the 0.59, but the -4, -5, maybe down here, -3, -4, -2, 3 is about right there. And if I were to go to this side of -4, let's say I pick -5. -5 plus 4 is 1. That would be -1, sorry. -1 to the third power would be -1. Minus 5 is -6. So here I have something. My graph is actually going to look kind of like this. Okay. Number 4 asks us to find the intercepts. And remember, if I'm finding the x-intercept, y has to equal 0. And if I plug in 0 for y, I have x minus 2 squared plus 0 equals 16. If I just simplify this, x minus 2 squared equals 16. I could do a couple things here, but to undo the square, I'm going to do the square root. And I have x minus 2 equals positive and -4. So this is really 2 sentences here, and I'm going to get 2 solutions. So I'm going to have x minus 2 equals 4 and x minus 2 equals -4. And if I solve each of these equations, if I add 2, x is 6. If I add 2 here, x is -2. So I have 2 x-intercepts. Now for the y-intercept, I have x equals 0. I'm going to plug in 0 for x. So I have 0 minus 2 squared plus y equals 16. 0 minus 2 is -2. Square it, I get 4. And subtract 4 on both sides, and y is 12. Okay, and that is my y-intercept. Remember that these actually represent points. So the points of the y-intercept or the x-intercepts would be over 6 up 0, over to -2 up 0, and this would be over 0 up 12. Okay, but these are the numbers of the intercepts that we have. Number 5, write the slope-intercept form, and I wrote the equation of what our ending answer is going to look like, with slope 5 containing the point 2, -2. So we want to end up with y equals mx plus b, but because we have a slope and a point, I'm going to start out with y minus y1 equals the slope times x minus x1, because I don't know the y-intercept, but I do know a point and the slope. So I'm going to plug in the values I know. Y minus -2 is y plus 2 equals my slope, which is 5, and x minus 2. And I want to end up looking like that. So I need to simplify and solve for y. So y plus 2 equals 5x minus 10. Subtract 2, and y equals 5x. I'm going to subtract 2, and that would be -12. And That's my solution. Number 6 says to write the general form of a circle with the center 5, 12 and the radius 13. So here is the general form of the circle. Remember that this center with coordinates 5 and 12, these are the h and k values that will go into the equation. So I have x minus the x coordinate of the center, so x minus 5 squared, plus y minus k, and k is 12, so I have y minus 12, and that is squared, equals the radius 13 squared. And instead of leaving this way, we should write this out again, x minus 5 squared plus y minus 12 squared equals 169. Okay, and that is the equation in standard form, or general form. Here's another one. Find the general form of a circle and identify the center and the radius. All right, so they give us this equation in standard form, and standard usually means have an equal 0 at the end. But this is one of those that we need to put it in general form so we can identify the center and the radius. So I need to complete the square. So I'm going to group my terms. I'm going to put the x terms together in one set of parentheses, x squared plus 6x, and I'm going to put the y terms together in another set of parentheses, so I have y squared, whoops, that's not a y, this is the y, minus 4y, and I'm going to send the 17 to the other side. And that was minus 17 here, so I'm going to add it over to the other side and have 17. So now we need to complete the square and make those perfect square trinomials. To get this perfect square number here, I take half of the middle term, so half of 6 is 3, and it's positive 6, so this is positive 3. I'm going to square it and put the number here. If I add 9 to this trinomial on this side of the equation, I need to add 9 to the other side. On this side, with the y's, I'm going to take half of the middle term, which is negative 2. I'm going to square it, which is positive 4. This is always going to be a plus something, because two numbers multiplied together that are negative will always be a positive number. And if I add 4 to this trinomial on the left side of the equation, I need to add 4 to the right side of the equation. Now I'm going to factor my perfect square trinomials, and that always gives me a square of a binomial. And inside the parentheses with x will be this number that is here. So this is x plus 3, quantity squared, and this is y, and minus 2 is the number I'm going to put here. That's squared. And I can always think, are my signs right? For the two numbers that multiply to be 4 and add to be negative 4 are negative 2 and negative 2. And on this side, I have 17 plus 9 is 26, plus 4 is 30. So now to answer the questions, what is the center? The center of this is going to be the opposite of the number inside with x, so this would be negative 3, and the opposite of the number inside with y is positive 2. My radius comes from this number, but this is r squared equals 30. So the radius is going to be the square root of 30. And thinking ahead, can I simplify this? If it's possible, we should do that. there are no numbers that are perfect squares that will go into 30. So center, radius, and equation is here. Number 8, it says for the line 4x minus 6y equals 12. The line parallel to that would have a slope of, and we need to find that slope, and then the slope of the perpendicular line. But looking at this equation, I cannot tell the slope. So what I need to do is solve for y. Okay, if I put this in slope and y-intercept form, then I can tell what the slope is. So when I solve for y, I'm going to move the 4x to the other side. This gives me minus 6y equals negative 4x plus 12. I'm going to divide by negative 6. And this is y equals, if I reduce this or simplify this, two negatives become a positive, 2/3 times x, and this would be minus 2. All right, so if this is my original slope, 2/3, the parallel line will also have a slope of 2/3, and the perpendicular line will have a slope of the opposite and the reciprocal. So this would be negative 3/2. And that would go there. Number 9 says find the equation of the line with the slope that is undefined through the point 4, negative 6. So we're going to talk about or think about a line that has a slope that's undefined. Okay, and if you remember, that means you can't have a 0 on the bottom, and it's the x-coordinates that are the same that gives us an x value on the bottom. So this actually is a vertical line. And remember, vertical line, you can't walk up the wall, so your slope is going to be undefined. Now, if I have a vertical line that always has an equation that starts with x equals something, and if it's going to go through this point, this means every x value will have the same number. So if this is my x value, the line x equals 4 will go through this point. Number 10, find the equation of a horizontal line through the point 2, 6. Now we can think of a couple things. First, horizontal line has slope of 0, and we also know that it is y equals something. Every y coordinate is the same. Here the y coordinate is 6, so the equation is y equals 6. You could also use y minus y1 equals the slope times x minus x1 and use the slope and the point on the line. So you have y minus 6 equals 0 times x minus 2. This is 0, and add 6, so you get y equals 6. And number 11, is the following function symmetrical about the x-axis, the y-axis, or the origin? So we have to test each 3, okay, and tell yes or no, is it symmetrical over each piece here? So if it's symmetrical over the x-axis, we have y equals the opposite of y, and if I plug that into the equation, I'll get the same answer. So if I rewrite the equation, I have x minus y has become negative y, and I'm going to square that, and I have equals 6. So in this case, I have negative y squared is still y squared. So I have x minus y squared equals 6. And yes, it is going to be symmetrical over the y-axis because this equation matches up with this equation. So yes, it is symmetrical over the x-axis. Now let's do the y-axis. In that case, I'm going to take x and I'm going to replace it with negative x. So here in this equation, I'm going to have negative x minus y squared equals 6. This is not the same equation. Minus x minus y squared does not match up because of this negative. This is not symmetrical over the y-axis. And for the origin, I have to replace y with negative y and x with negative x. So x becomes negative x minus y becomes negative y, and I'm going to square that, make sure it equals 6, and I simplify this. This becomes y squared. So I still have negative x minus y squared, and it is not the same because the negative, and it is not symmetrical over the origin. So there we have it. And make sure you ask questions if you have questions next time we meet, and good luck on your test.